Hello everyone, in this video we are going to discuss about exercise question 3.13 of class 11 physics from the chapter motion in a straight line. Let us go through the question first. Explain clearly with examples the distinction between magnitude of displacement over an interval of time and the total length of path covered by the particle over the same interval. Then magnitude of average velocity over an interval of time and the average speed over the same interval. Then show in both A and B that the second quantity is either greater than or equal to the first. And when is the equality sign true? And for simplicity, consider one-dimensional motion only. So, first let us see the distinction between magnitude of displacement and the total path length. You see, magnitude of displacement over an interval of time, it is the shortest distance or the straight line distance between the initial and final position of the particle. We will discuss in detail. And the total path length of a particle, it is the actual path length covered by the particle in a given interval of time. So, for example, consider I'm just considering a straight line road because we are considering one-dimensional motion only. Suppose this point is A, this point is B and this point is C. Suppose from A to B the distance is 20 meter. From B to C the distance is 10 meter. Okay, now suppose a particle moves from this point A, okay, to a point C, then comes back to the point B. Okay, that is a particle is moving from a point A to the point C, then it is coming back to this point B. Okay, by taking total time, say 10 seconds. Okay, so what will be the magnitude of displacement of this particle? See, you see, this is the initial position. Okay, and you see the particle reached here at last. So, B is the final position. So, what is the displacement? Displacement is AB. Okay, so displacement is AB here, which is equal to 20 meter. Alright, now, what about the total path length? Total path length first is travel from A to C. So, AC plus, then it traveled from C to B. So, AC plus BC or CB. Okay, AC 20 meters plus BC, which is 10 meters. So, which is equal to 30 meters. So, you see magnitude of displacement is 20 meter only. But the total path length is 30 meter. Alright. You see, the magnitude of displacement, this can never be greater than the total path length. However, in some cases, both quantities are equal to each other. That is, magnitude of displacement can be equal to the total path length or it will be less than the total path length. Magnitude of displacement cannot be greater than the total path length travelled by an object. Now let us talk about the distinction between magnitude of average velocity and the average speed. So you see, what is magnitude of average velocity? This is actually equal to the magnitude of displacement divided by the time interval. Okay, so in this example, what about the displacement? Displacement is AB divided by the time taken as 10 seconds. Okay, that is 20 by 10, which is equal to 2 meter per second. Okay. Now what about the average speed? Average speed is equal to total path length divided by the time interval. So in this example, total path length is actually what? AC plus CB, which is 30 meters, right? Divided by time taken as, sorry, not 30 meters, no. Total path length is, I'm sorry, AC is actually here. You see AC, which is not 20. AC is actually 20 plus 10, which is 30. Okay, then BC 10. So, this is actually 40. I'm sorry for that. Okay, so here total path length is 40 meters. So, here 40 meters divided by time taken as 10 seconds. So, this is equal to 4 meter per second. Okay, so you see average speed is greater than the magnitude of average velocity. See, the two quantities, which is average speed and magnitude of average velocity, will be equal if the particle continues to move along. That is, suppose the particle starts its motion from this point A, it moves along the straight line and reaches here C, and it stops its motion at this particular point C. So its motion is a straight line motion, started from A, ended at C. So in this case, you see, suppose the particle has reached at this particular point C by taking 5 seconds of time. So in this case, what about the magnitude of average velocity, which is actually displacement by time taken? Displacement is 20 plus 10, which is 30 meters, divided by time taken as 5 seconds, so which is equal to 6 meter per second. And what about the average speed in this example? See, average speed is equal to total path length, which is AC, 20 plus 10, which is 30 meter, divided by what about the time taken? 5 seconds. So you see 6 meter per second. That is, these two quantities, average speed and magnitude of average velocity, will be equal if the particle continues to move along a straight line. Okay. So I hope it is clear to you. Thank you.